Imagine waking up one morning and seeing a headline that completely changes the direction of human history. Faster than light travel is now possible. At first, your brain refuses to accept it. The idea feels unreal, like something out of a science fiction movie. But as you continue reading, you realize this is not a fantasy story. This is being discussed in real scientific research papers using real mathematics based on Einstein's theory of relativity and modern quantum physics. Suddenly, the universe feels different. The stars are no longer unreachable points of light. The galaxies we have observed for centuries are no longer just distant mysteries. They become places that humanity might one day reach directly. This changes everything about how we think of space. But before imagining interstellar travel, we must understand something deeper. Why did science ever believe there was a speed limit in the first place? Why the speed of light became the ultimate limit? The foundation of this idea begins with Albert Einstein and his theory of relativity. Before Einstein, space and time were thought to be fixed and separate. After Einstein, they became part of a single flexible structure called spacetime. In this framework, the speed of light is not just fast, it is the maximum speed at which information and causality can move through the universe. This speed is about 2.9979245, 8 meters per second. But the real reason it is a limit is not because light is special, it is because space-time itself imposes this boundary. When an object with mass accelerates closer to light speed, strange effects begin to appear. Energy required for further acceleration increases dramatically. Time slows down for the moving object compared to outside observers. Distance contracts in the direction of motion. If an object could actually reach light speed, it would require infinite energy. Its mass would become infinite and time would completely stop. This is not theoretical guesswork. It has been tested repeatedly in particle accelerators where particles behave exactly as relativity predicts, even at extreme speeds. Cosmic rays also produce particles in Earth's atmosphere that survive far longer than expected because time dilation allows them to travel further than classical physics would allow. This confirms that the speed of light is not just a suggestion, it is a fundamental structure of reality. What most explanations miss about the light speed limit? Many explanations stop here, but there is something deeper often missed. The speed of light is not just about motion, it is about the structure of reality itself. It is connected to how cause and effect work in the universe. If anything could move faster than light, it would break the order of cause and consequence, allowing effects to happen before causes in some reference frames. This is why physicists treat it as a boundary of reality, not just a speed limit. But even with this understanding, a new question emerges. Is it possible that the universe allows shortcuts instead of breaking this rule? A radical idea moving space instead of moving through it. In 1994, physicist Miguel Alcubierre proposed a solution that changed the entire discussion. Instead of trying to move through space faster than light, what if space itself could be manipulated? According to general relativity, space-time is flexible and can stretch and compress. Alcubierre suggested a concept where a spacecraft sits inside a region of space-time called a warp bubble. In front of the bubble, space contracts. Behind it, space expands. The spacecraft itself does not move locally. Instead, the bubble carries it through space. This means the ship is not breaking the speed of light inside its own frame. A useful analogy is a moving walkway at an airport. You are standing still, but the walkway carries you forward quickly. Inside the bubble, physics remains normal. From outside, it may appear that the ship is traveling faster than light. This idea fits within Einstein's equations, which is why scientists take it seriously. Even though it sounds extreme, it suggests that interstellar travel might not require breaking physics, but instead using physics in a different way. What the competitor missed the deep physical problem. Most simplified explanations stop at the idea itself, but there are deeper issues. The first is energy. Initial calculations suggested that creating a warp bubble could require energy comparable to the mass of an entire planet like Jupiter converted into pure energy. This is not just large, it is beyond any known physical engineering capability in the universe. Even stars do not produce energy in this controlled form. The second issue is stability. Even if a warp bubble could be created, it may not remain stable long enough for travel. Small fluctuations in spacetime could collapse the bubble instantly. The third issue is interaction with matter. Particles in space could accumulate at the front of the bubble and release extreme energy when the bubble stops, potentially destroying everything nearby. This is one of the most overlooked dangers in popular explanations. The fourth issue is causality. Inside a warp bubble, communication with the outside universe may not be possible because information cannot cross the boundary in normal ways. This creates a situation where steering or navigation becomes extremely uncertain. These problems show that the idea is not just about building technology, but about controlling the fundamental structure of reality. Modern research and why scientists still do not reject it. Despite these problems, physicists continue to study the concept because no law of physics explicitly forbids all versions of it. New theoretical work has suggested modified models that reduce energy requirements significantly compared to the original proposal. Some versions suggest that exotic matter requirements may be reduced or replaced under certain conditions. At the same time, quantum physics is revealing that empty space is not truly empty. The Casimir effect shows that quantum fluctuations in vacuum space can create measurable forces between objects. This proves that negative energy conditions are not purely imaginary, at least at microscopic scales. Scientists are now studying whether such effects could ever be controlled or amplified. In addition, advances in metamaterials have shown that we can manipulate electromagnetic waves in ways previously thought impossible. We can bend light and control wave behavior in engineered materials. While this is not space-time manipulation, it shows that our ability to control fundamental physical behavior is improving. What the competitor also missed the cosmic scale perspective. Even if faster than light travel becomes possible, there is a deeper cosmic limitation that is often ignored. The universe itself is expanding, and this expansion is accelerating. This means that even light from some galaxies will never reach us no matter how long we wait. There is a cosmic horizon beyond WH. The universe becomes permanently unobservable. This means faster than light travel would not give access to everything in existence. Some regions of the universe are already lost to us forever due to expansion. This adds a philosophical layer to the problem. The universe is not just large, it is dynamically separating itself over time. The quantum nature of reality. At the smallest scale, space-time may not be smooth. Instead, it may behave like a constantly fluctuating structure, often described as quantum foam. Tiny distortions may appear and disappear continuously at microscopic scales. Some theories suggest that microscopic wormholes could form and vanish within this foam. Quantum entanglement also shows that particles can remain correlated across vast distances in ways that challenge classical intuition. Although this does not allow faster than light communication, it suggests that reality is far more interconnected than it appears. Space and time may not be rigid structures, but emergent properties of deeper physics. What faster than light travel would actually change for humanity? If faster than light travel ever becomes possible, it would completely transform civilization. Humanity is currently limited to a single star system. Mars is difficult and dangerous to colonize and still within our solar neighborhood. Beyond that lie stars that are thousands of years away using conventional technology. With faster than light travel, everything changes. Exoplanets become reachable destinations instead of distant observations. The galaxy becomes accessible space instead of unreachable background. humanity evolves into an interstellar civilization. Scientific discovery would accelerate dramatically as we explore different star systems directly. We might discover new forms of life or entirely new cosmic phenomena. Economically, access to asteroid belts and planetary resources could remove traditional limits of scarcity. But the risks are equally large. Interstellar conflict becomes possible. Ethical questions about interfering with alien ecosystems become real. Civilization itself would need new frameworks to handle such expansion. Final perspective. What competitors usually miss. Most explanations end with excitement about the future, but miss the deeper truth. Even if faster than light travel becomes possible, it will not simply be a transportation breakthrough. It would represent a complete shift in how humanity understands reality. It would mean learning how to manipulate space-time itself. And even if it never becomes real, the attempt to understand it is already transforming physics. The universe is not static or simple. It is evolving, expanding, and full of unknown structures we are only beginning to understand. And humanity is not separate from this process. We are part of it. Every question we ask pushes the boundary of knowledge further. And somewhere within those questions lies the true future of human civilization among the stars.